So just the two examples. The charge life of a certain lithium-ion battery is normally distributed with mean 90 minutes and standard deviation 35 minutes. So A, determine the probability that a randomly selected battery lasts more than 100 minutes. Is this unusual? B, determine the probability that a random sample of 10 batteries has a mean charge life of more than 100 minutes. Is this unusual? And C, determine the probability that a random sample of 100 batteries has a mean charge life of more than 100 minutes. Is this unusual? All right, so starting with, not red. Looking at the question, I'm told the charge life of the battery is normally distributed with a mean of 90 minutes and a standard deviation of 35 minutes. So this is information about the population. With the mean, well, first of all, it's normal, so that's important. And then the mean is 90, and the standard deviation is 35. Question A, determine the probability that a randomly selected battery lasts more than 100 minutes. Is this unusual? So we're working in the population that is normal, has a mean of 90, and standard deviation 35. And we're asked the probability that X is more than 100 minutes. So we're going to use the StatCrunch calculator. So bringing up the normal calculator, stat calculator, normal. We put in our mean of 90, our standard deviation of 35, and we want the probability that X is greater than 100. And we remember that greater than and greater than or equal to are the same in a continuous distribution. So this looks about right. The mean here at 90, and we're looking greater than 100. So it's almost half of it. I wanted to show you this button here that has the different colored ticks here. If you click on that, it puts the mean marked in the center, which is kind of nice. So notice now that the mean is actually marked right here at 90. And then this is +1 standard deviation of 35, +2 of 35, and +3 of 35. So it kind of does the whole thing for you. And you can see that we're pretty close to the mean, so we expect to have that nearly 40%. So our answer would be 0.3875 when we round. So we can go back to our Word file, and we have that the probability that X is greater than 100, and now I forgot it, is 0.3875. They ask if it's unusual. It is not unusual because it's greater than 0.05. And that's how we decide. All right, part B. Determine the probability that a random sample of 10 batteries has a mean charge life of more than 100 minutes. So now we have a random sample of 10 batteries. So that tells us we're dealing with a sample with n equals 10. I like to write things down as I find it so I don't have to go find it again. And now we want the probability that the sample mean is more than 100. So the probability that X bar is more than 100. Interrupt me with questions if you have them. Since we're looking for a sample, if I look down my formula sheet for a sample mean question, it tells me that I need to find mu sub X bar, which is the same as mu, so it's 90, and sigma sub X bar, which is sigma over the square root of n. So sigma over the square root of n here is equal to our sigma from before of 35, but now we're dividing by the square root of 10. And when you do that calculation, you get 11.06. If we go back to the normal calculator with the mean of 90 and now sigma of 11.06 and do the probability, we get 0.1830. So now we see that that is not unusual because 0.1130 is more than 5%, 0.05. Any questions? Okay, and then for C, so that was B. For C now, we have determined the probability that a random sample of 100 batteries has a mean charge life of more than 100 minutes. Is this unusual? So again, we're dealing with a sample, but now n is 100. And we're looking for, is the sample mean, what is the probability the sample mean X bar is greater than 100 minutes? So we have to find, our formula sheet tells us, find mu sub X bar is mu, which is 90, but we have a new sigma X bar, which is sigma over the square root of n. So we have 35 over the square root of 100, which is 35 over 10, so 3.5. We go back to the normal calculator, now using 90 as our mean and 3.5 as our standard deviation. And that's going to give us 0.0021. That is unusual because 0.0021 is, less than 0.05. So it is unusual. Any questions?
So when it's okay, so not unusual, the rule of thumb for not unusual is greater than 0.05.
Correct.
That's it.
That's it.
And if it's usual, it's less than 0.05, right?
Correct.
Okay. All right. I'm just double checking. Thank you.
You're welcome. One thing sometimes students have trouble with doing is comparing the 0.05 to, which only has 2 decimal places, to a number with more decimal places. So if you have 0.0, let's do 0.0483 and 0.05, they get confused. How do you compare them? So what I like to say is make them both 4 decimal places and then ignore the decimal. So with 483 and 500, that immediately tells you it's less. So it's just a little trick to compare those.